So I'm currently trying to get up to speed on Serial's HB branch, and there's an error message here that says unknown test driver, and I happen to know that this is because there's a mismatch of lake versions between 4.8 and 4.9, and this is caused by old version of the .lake directory. And so I removed the .lake directory, and then I'm reconstructing it using lake exe get, and now it's happy. And if I do like world mathdiv.hb, then it should, good.
It should error.
Well, it shouldn't error before getting to HB, and it did, so that's good. So see the errors here, that's good sign. This is good errors, that's a bad error. And then I restart file.
How do you restart the file?
So I have some keyboard commands here, so I'll show you what I was doing. So I did restart.
You mean server, restart server?
No, there's restart. So you can see there's restart server and restart file. I actually tried restart file first, and it didn't get rid of that error. And then I did restart server, and it did, and that's because the server was still running the 4.9, and then I was checking out your branch, which shot 4.8, and so that's what's better. Okay, so now we're all good, and we have only the intended errors. Okay. So you changed this to math. We have math.
The next thing first.
So. All right, where were we? We were working on mix-ins, and you had this interestingly complicated pattern match.
So it got even more complicated when Sebastian told me to match only on strict simple binders, so it's restricted now. This is the way to get the pattern matching simpler.
Because you added this line, you mean?
Yeah, but this match is only on one of the syntactic constructions. You can go to the declaration of class to see in the...
You mean this class?
Well, yeah, if you control click, you can get the definition of class.
Not on this one. But
yeah.
if we control click on an actual class.
Yeah.
Do you actually use a class?
Yeah, up, there, up. Oh, okay. Now you have one. Oh. I was expecting you would start explaining, because you explained that to me yesterday.
Yeah, so all right.
I mean, last week.
All right, so I'll explain a little bit of what's going on here. This is for writing this very complicated line here. So you're defining class, but with the word class replaced by mixin, and then all of the rest of this stuff is based on the declaration. I suspect that it's going to keep cutting out like that for like a couple seconds at a time. This is the partial for a declaration. So it says that a declaration consists of some modifiers.
Breaking down, yes.
Yeah, I don't know what it is.
But can I ask a very ignorant question? Because I know that Sarah was talking about HB, the hierarchy builder, over the last week. But as you know, I was not here last week.
So you need an intro to what we're trying to do.
Could you have
one
sentence about what is happening here?
I think even 2 minutes would be okay, because we were not all present in the hierarchy builder.
I guess the part of it that's relevant at this point is actually, the idea is that it replaces some portion of, where is it? It replaces some portion of Lean's class and structure commands with additional commands, and then they have additional logic, but at this point, none of the logic's happening, and it's just parsing class.
So it's an alternative to the class command. So the alternatives will be mixing, for the purpose of the demo, mixing math class, just to find another name than class, and factory, that we will compile to Lean code and produce the Lean class with some modifications and subsequently the new definitions attached to those objects, and subsequently register links between all those things. So we want first to make a syntax that looks like the class command for each of those new constructions, and we want to explain to Lean how to translate them to a class and more things. And those are done in two separate phases, one for the syntax and one for the elaboration. And those are more things. Those are more things that you want to add. So we need to register which class is a subclass of which other class. We need to register. So we will change how the inference of operators of a class is done. So instead of attaching it to small pieces, we will always attach it to the big classes. So we need to change the way that Lean refers to an operator and say it goes to this instead of that. So we will need to remember where it has been declared in order to avoid some duplication that Lean always performs. I mean, when you write mul, if there is a mul in there is a mul in every single class that inherits mul, right? And we want to define one that is generic and that will stop it.
So are you gonna just implement everything in Lean in parallel, or are you using the hierarchy builder in the background to tell you which things to do?
So a hierarchy builder is the name of the Coq plugin that does exactly what we're trying to reproduce.
I see. But there's some kind of a thing that computes the lattice or whatever.
Yeah, so that's what we're going to implement. I mean, a hierarchy builder for Coq is both the name of the language design, of the domain-specific language, and the way it's compiled down to Coq, and we're going to do the equivalent in Lean, except Lean already covers parts of the features that we are trying to implement, so that we'll have to produce less boilerplate code than we have to in Coq, but probably in a different way.
And why Moulon? Why MUL?
So this is a toy example. Yeah, it's a toy example about a multiplicative monoid, and it will consist of 5 structures, like one mul, mul1, semigroup, and monoid. So that's every class. So part of the logic is every class can never extend. So we need to regroup the data in mixins, and at some point we decided that there would be an empty bottom class that everyone inherits.
Okay.
I'm not sure it's a good idea, but we reached a consensus that we should try.
Okay, so bottom is supposed to exist already, and it's like
Yeah,
part of hierarchy builder.
it's somewhere up there. So we have 3 phases in this file.
Is bottom an element or a bottom type?
Bottom is a type. It's a class.
It's a class. It's a family of.
The bottom class, as it were, which has nothing.
It's sort of the root of the hierarchy.
Okay. I just work out whether it was the class or the element, right, with you, yep.
I don't know if this is going to take us way too off track, but can you explain on the example that you're trying to do? What's the difference of what they should produce compared to the extends class mechanism in Lean?
So
we have here some code that is actual Lean code.
Yeah.
This is the top of the file, and this is the bottom of the file. And this is the code that we want to write. And as you can see, it's failing because we aren't done yet. And this, I guess, the idea is that this code should produce this code. Is that right? Yeah. So it's gonna automatically like work out, when you write mul of bottom like this, it will generate this stuff.
yeah, so right now it's almost a duplicate, except for a few little changes.
Okay.
And does it make a difference if you generate the code or directly the expressions or whatever the right level would be?
It's easier to generate the syntax and then let Lean elaborate that syntax. It's more flexible if you can generate, if you can call those functions directly or like translate that to the lower level, but it's also significantly more verbose to do that.
Okay.
But both options are available. Okay.
So what is the precise advantage of the presentation on the left compared to the one on the right? Is it just that it's shorter?
It computes some things in advance that it's able to check more invariance than this code can.
Okay.
It's like, I don't know, you tell me. What are the advantages?
So we could, whatever the syntax on the left is, the point is to be able to indeed to perform more checks. Like one of the checks we want to perform is that there is only one instance, because multiple instances are very problematic. We want to perform static checks at every instance that whatever you add is actually compatible with whatever you already had registered. And for that, you must always keep track of the dependency graph. And
But don't you sometimes want different instances? Or maybe you have some object and you want different topologies on it?
Yeah, but you shouldn't do that. You shouldn't do that by inheritance like this.
Okay,
Yeah,
so that
so-
should then be separate from the instance.
So the way that Lean currently handles this is through
Aliases.
type aliases. So you can say that
Okay.
yeah.
And you want to
Just wrap your
enforce.
type into some other.
Yeah, you give another name to your other type for which you will have another. For the same type with another topology,
Okay.
so that. And the point is, since you will give another name, the code that we will write will be able to check statically that on a given name there is only one instance of the topology.
Okay.
And not one coming from another metric or whatever.
Yeah, and I'll give you a basic example of this that I happen to have been looking at recently. The simplex category, you can see it's just defined as nat, but the category itself is more than just the objects. The objects are nat, but the morphisms are something more complicated, and we want to put an instance of having a category that tells you that the morphisms between these are some monotone maps, but we don't want to put that instance on nat because that's not like the canonical. Probably if you ask what's the canonical category structure on nat, it would be like the preorder, right?
Yeah.
So this is a way of saying, no, I don't want that one, I want a different one.
Can we maybe fetch another cable, because it's really,
Yeah. I mean, it might be my computer. I don't know.
It didn't happen.
No, this happens to every computer.
But it didn't happen that much.
It didn't happen with mine, for example. Yeah, that's the problems with the solution.
Okay, so there is at least, you can have a good enough computer so that
Okay.
But I think the guy who kind of set it up has already gone, so.
Yeah. I mean,
I think we have to suffer.
he's hiding in a closet somewhere, watching this whole thing.
I don't know where to find the person.
I think some of them are
I
in the
think-
basement whenever they are in the basement.
They are not right now.
The mouse, I think, has gone. Sorry.
I think we should just keep going.
Not so bad.
All right, so we were talking about how to fix this, I guess. So, what is?
So we were talking first about, I mean, if you want to make a tutorial, maybe we should start again with mixing, because that was the easy one.
Okay.
Okay.
Well, easy in the beginning.
Yeah, it's easy.
In the beginning, but you can throw away.
Do it from scratch.
Okay.
Let's throw away this piece of code and just make it a duplicate of class.
Okay.
Just making an identity command.
Okay, so maybe I'll skip the definition of this syntax, but basically, I'll tell you what's here, but I won't rewrite it. So what this is, so if we go to command, we were looking at declaration, and this is where is it? Yeah. So this is like when you write down, so lean is structured as a bunch of commands, right? So open is a command, syntax is a command, macro rules is a command. There's a bunch of very strange commands here. Initialize is a command. Print is a command. But like def is also a command. And so most of the time when you're writing declarations, you're going to be seeing things like def and theorem and command. And so all of those are actually parsed with this declaration function. And so you look at this once it comes back, and then you see that it starts with some decal modifiers. So that means like, okay, it has a dot comment. It has some attributes, protected or private, non-computable, unsafe, blah, blah, blah. There's some modifiers. And then there's all these different kinds of declaration. In this case, we care about structure, which both structures in class count here. So you see structure TK is defined to be a structure. So this structure in quotes means that it's going to parse a token, and the token is structure. And then similarly here, we're going to parse class. And then an identifier here. And then some binders. Oh, my goodness.
Yeah.
Some binders, an extends, and a type. And then colon equals some the name of the constructor, and then the name of the fields, and then deriving. So like a lot of these are like weird optional extra things that most people haven't seen. Just to clarify what this looks like, where would this classify? Okay. So here's a reasonably canonical example of.
Yeah.
Your presence seems to be enough for that to start working.
Maybe we have to change something and then maybe. And less.
Oh,
It's bigger.
Okay. Yeah, this one.
the resolution changed.
The resolution is a little bit lower, but if it's still good, then we'll be happy. Okay. So, a class.
Ooh.
Is that still readable?
Keep it a bit larger.
Did you make it smaller?
Yeah.
The resolution changed when you, but maybe you can recover the old resolution, no? Okay.
I tried myself then.
This is fine.
I guess it's slightly possible that it was the resolution that was the problem.
Possible. So this is a class. This is, what new classes normally look like. And you can sort of recognize the tokens that are coming out of this. So like we have a class token, and then we have the decal ID, and then we have the binders. That's these bracket binders over here. And then we have the extends, that's this optional extends. And then we have either colon equals or where. And then there's no construct ctor here, but if you wanted, you could write make : Usually the only reason you would do this is if you want to document it. So that the, so this is the constructor of the class, so this takes in one thing of each of the types, and normally the syntax you'll use to call this thing is the braces and then the names of the fields. And this is where you would put the document.
Can you repeat what you mean by document? In order to get a doc string, you need to put the constructor name?
Yeah, you can't just like put a, you can't just put this.
Ah.
So if you wanted to put documentation specifically on that declaration, not like the, if you wanted to put on the type, then you would put it at the top, right? But if you wanted to document the constructor, then there's no obvious place to put that, so that's where it is. But this allows you to, and this is also if you wanted to name it something else. The default name is make, or MK. Right, so that's the CTOR and then the struct fields. And the struct field has, so most of this is just saying like, it's many, and then the indent is talking about how it parses, like, how the alignment of these things is actually relevant, I believe. I'm not lying. Yeah. So I think they have to be, I think this is the more permissive one. It requires that all of the subsequent ones have a greater or equal indent to the first one.
Isn't that the check call GE?
That is, oh yes. So maybe it's a combination. The part, let's see, it's equivalent to with position of call GE. So no, I think the call GE here is redundant.
Oh.
Yeah, the call GE is already built in.
What's the funny triangle after many indents?
So this is the same as parenthesizing all of the remainder, but it has low precedence.
Oh, okay. I didn't see that.
This is also an ASCII triangle.
Yeah, Sebastian told me that there was no Unicode for it, but
It's written like this.
Oh, okay.
But I have a fancy programmer font that.
Okay, because I know the ASCII.
Yeah, you can see that it's actually 2 characters.
Ah. Yeah.
That's a ligature. This is also a ligature. Anyway.
So which fonts do you have?
Fire code. It's pretty good.
Code? Okay.
Anyway, so a struct fields is a list of, these are all just pretty printer things that don't do anything. And then this says it's either a explicit, implicit instance or simple binder. And the only difference between these is the kind of brace that is being used. So an explicit binder can have parentheses, braces is implicit, square brackets is instance. And so you'll often see these in regular binders, like this. You can write, using this kind of syntax or using this, and they mean different things in terms of how they get used. So, like using braces means that it's not to be passed explicitly, and so here I'm passing it explicitly, and that's an error. But you can also, what this is saying is that you can actually put this on the fields, right? So you can put braces around these fields.
Oh.
If you want to, and that affects, like, you'll see if I do this and look at the type of the make, you'll see that 1 mol is now in these square brackets. So that's where that affects.
So I think we didn't have the other day any problem with this parsing things, and it's pretty standard. Instead, a question: what is the type of these things? What is the type of what is parsed?
So okay, so we have this. So all of these things are, I look at this code and I see this leading parser, whatever, and no one's rating the types on anything. All of the types are just parser, and this is basically a combinator language for being able to describe parsers. And so this is how Lean itself defines the parsers. And as you can see, we can use it also for trying to figure out how, what order things come in and how things are parsed. There's another syntax for writing parsers, which is the syntax command. And that's actually what we were using here. And so the reason I was going through this was because I wanted to compare and contrast this definition of the structure with this definition here. And basically the only difference between these two is that this one uses mixin and this one uses structure or class. But there's also a bunch of syntactic changes having to do with the fact that this is declaring a syntax and this is just a plain def. And I think this is only for historical reasons that these are using def. This is sort of the new syntax that is preferred for writing.
That's what Sebastian told me this morning, that we shouldn't be using this. This.
So maybe at some point in the future, these will be changed to use syntax. This uses, like, instead of using this double greater than sign to indicate adjoining parsers, this uses just adjacency, which is a little bit confusing at first if you're thinking about adjacency as meaning application, like it means everywhere else in the language. Here it means just subsequent parsers. And then actual application is using parentheses with no previous space. So I think this is relevant. This syntax of like an identifier and then a parenthesis with no subsequent space is actually disallowed for application and is used for macros in the regular language of Lean. And then we have the star here that means 0 or more, and then the question mark means 0 or 1. And then another thing to watch out for is that because question mark is an identifier keyword, you actually have to separate it when using it in this particular context, which is a little bit.
Silly question, the funky quotation marks around extends, that's like a literal match or?
So you can see by the blue color that extends is a keyword. Extends is actually made to be a keyword because it is used as a token right here. And so structure and class and extends are all keywords, which means either you've got to do something like this where you write TK at the end, or you can actually use the exact same name, however you have to put it in these French quotes.
I see, okay.
That allows you to use anything as a keyword, even if it has, dot or space or other weird things in it.
But so the question is, why extends is like that, and where instead is?
That is a great question to ask Sebastian. Why is it that only some of them are using the quotes?
This is one of the things that were puzzling us the other day. Some needs the French quotes, some don't need the French quotes.
Well, so most of them don't need French quotes because they're not, like in this example, none of these are actual keywords except for extends. So that's why this is the only one that has. The other question would be like, well, why is it that this one was defined to be extend, whereas most of the others are not using that, and that's depends on how people see it.
Is there any reason why I think class gets a separate definition as a token, but then where appears just literally in the parser?
So there is a technical difference. When you use a string here in this combinator language, it parses to an atom. So this is so I can actually show you the definition of syntax. That is not the definition of syntax. So syntax it's basically composed of nodes, atoms, and idents. So an atom is what you get out of these quote things. And so this is like when you parse some literal syntax, it's going to be a string containing whatever the syntax was and some info. And then an ident corresponds to user-provided identifiers of some kind, some open syntax class there for being able to write down names, and then they're also sort of resolved in some ways. And then node is, they are marked with a syntax node kind, and these syntax node kinds actually come from the names of these declarations. So like when you use leading parser in this syntax, and also when you use the syntax command, it will actually tag all instances of this parse. Sebastian is walking. It will tag all instances of this parse with the name of the declaration. So this will actually get wrapped in a node whose name is lean.parser.command.extends. So to your question, like what's the difference between having just the quotes and having the quotes brought into its own definition is that this is actually going to parse not an atom, but an atom wrapped in a node with the name class tk. And so that will help like matching it later on. Whereas this one, it's just the atom where. Okay.
So it means that if you omit the tk in class tk and put French regular quotes, it will not be the same syntax tree.
It will not be the same syntax tree. Yes, that's correct. There's another way to do leading parser where there's a node parser. You can say node and then the name of the thing, but usually node parsers use the declaration name of the thing, and that's also useful because in various places, for instance, when I control click on this and it takes me to the definition of elab syntax. Or I think this one also that takes me to the definition. The reason why those links work is because it's actually taking advantage of the fact that the name of the syntax that was parsed in this location is the declaration name to go look up. Yeah. All right. So I guess, yeah, we were going to rewrite a macro rules. So here, okay, so what are we defining here? So we have a syntax that has a whole bunch of arguments, and this is our mixin command. But like, if you just try to use mixin, like a simple example, mixin x, that would be valid here. And then what error do we get? We get elaboration function for mixin has not been implemented, and that's true. It has been implemented down below. So once we move past all this code, then using it will work. And I guess in this case, it produces a class. So you can see that this macro rules is sort of attaching, like the first part, like if we use mixin back here, it says elaboration function has not been implemented. If we use mixin back here, it says unexpected identifier. It's just completely not parsing it, right? So the syntax is really about parsing the syntax command, that is, and then the macro rules is about saying what it's going to expand to. So there's basically two ways that you can say what a piece of syntax expands to. One of them is macro rules, and then the other one is elab rules. Macro rules is when you say that a piece of syntax expands to another piece of syntax. So that's great for really simple commands or things that are just sort of abbreviations. You can say, here's some more lean code that I want this command to just do the same thing as that's doing. And in this case, we're using that. If all we wanted was to write something that was identical to class except with a different keyword, then all we would have to do is replace the initial mixin with class, change the syntax kind, and then we're good. The pattern matching here has to do with all the different ways that one can write this code, and like all of these things have to be matched in some way. So like a really simple version of this, if I wrote this, then this would work in the simple case. And it says, yes, this is a class of, right? But now if I use any of the other fancy things like this, now it says elaboration function has not been implemented again. So you can actually have multiple rules for the same, you could have another one.
And what is the type of ID?
So ID here is, so inside this block, you can actually see the types of everything that you get out of this pattern match. In this case, ID is a decal ID. And so
You mean it's a T syntax decal ID?
it is yeah, fair enough. So each of the things that is coming out of here is a syntax. That is to say, the syntax type that we were just looking at. However, it's wrapped in this T syntax thing. T syntax is just a syntax, but it's tagged with the node kind that it came from. And so this is helpful for sort of writing well-typed syntax transformations to avoid mistakes where you stick some, expression in missing like a list of length 1 or something that was required by the parser. Now everything goes wrong. Right, so like in this case, I've parsed
so there is nothing to
yeah, so here's a slightly more complicated parse where now it's happy about my mix in X with X of type because I said, yeah, it's okay to have one binder with this shape and then, and that still works. So this is matching binders. I could say I'm matching multiple binders using this $ bracket and then a star at the end. And now I'm matching 0 or more binders, right? So that works. But if I wanted to match this in general, I guess what I want to match is a list of bracketed binder because that's what's in here. I can say X bracketed binder. I think I don't need to write that. And I can tell whether I need to write it because the types are telling me that this is a bracketed binder, which is but I can say it's a bracketed binder here.
When you had written X colon Y star, is it 2 arrays, X and Y, or how can you, what's the type of X and TY?
Good question. So you can see that X and TY are type ascribed as syntaxes here, but you can see in here that they're actually arrays of syntaxes. So actually the code that is generated by this is in fact unzipping this thing into a bunch of arrays. And then conversely, I can pass them in here with the same essential syntax, and it will map them back together into one.
But it does even more. It maps them into binder, bracketed, unbracketed binder, or bracketed binders. So it's because it's written in the same way as bracketed binder are?
Yeah, I mean, so here we need to produce a bracketed binder. There's several ways to produce a bracketed binder. Again, with the implicits or explicits, you can use multiple kinds of parentheses. But here I'm actually saying I want it to be round braces. I could actually have a thing that like changes the round braces to curly braces. And so now you'll notice that it was actually declared with curly braces even though I wrote round braces. So this is an example of...
I mean, really, is this the same syntax nodes as the bracketed binder, or is there a cast that...
So this braces is being parsed into a bracketed binder. It's expected a bracketed binder here. It's expecting a list of bracketed binders, and since I use this $ thing, it's saying each of these things is a bracket binder. So to the extent that it needs to perform coercions and so on in order to get it to be a bracketed binder, then yes, it is inserting those. So this is producing a syntactically correct syntax tree that inserts X and at the right types.
This is dark magic.
Yeah,
This is Sebastian's dark magic.
that was completely obscure to us, trying to understand what was going on.
Yeah, I should add that these coercions are not currently automatically generated in any way, which you might expect from some parsers. It's not that dark magic. So these coercions are actually written down by hand. Like you will find I don't know, a handful of coercions in core, maybe more in math, but I actually don't know.
So are there coercions? I mean, like type class standard lean coercions?
From T syntax X to T syntax Y. It's using the standard Cody class.
And another question, is a dollar bracket star just one thing, or is dollar bracket is one thing and star is another thing?
Dollar bracket star is one thing.
It's one
Yes.
But there's a couple variations on it.
Yeah, exactly. There are variations.
That's what we got wrong.
There's question mark for optional. There's comma star
That's
for
Master.
yeah, list with separators. The comma could actually be something different, but yeah, it's basically always comma. Oh yes, and that one is with what optional trailing comma.
No, but can you, if you write comma star, it doesn't work anymore?
Yes, because it's not expected at this place.
Right, so this is supposed to have a bracketed binder. Here, yeah, let's create a version of that. So we'll say that this is bracketed binders, but with commas between them. So we have to put a comma there.
Ah, yes, you have to patch the syntax accordingly. Okay.
Yes.
So if I try to match either way in the wrong way, then it won't work.
Yes, so that's
the problem we had.
the unfortunate part of this entire thing is that the parsers for this are very fragile. So especially the dollar brackets, either you get the all the syntax within the brackets just right, or it will fail immediately on the dollar. Like there's no incremental response here about what exactly is wrong in the brackets.
Yeah, the errors here are not big.
Yeah, exactly. And the simple reason for that, I mean, maybe we could improve it, but the simple reason is that we don't know which part you want to bracket yet. It could be some optional part. It's not clear how much we need to skip. So yeah, that's why we either fail completely or succeed completely.
And just to show this version of the parse, I forget if I have to put it in here.
It's,
I think
Oh yeah, I guess
it's the same.
really doesn't matter.
So this one allows you to put a comma at the end, optionally. And those both parse.
But
So
then
that's what this
you're only giving semantics to the one without?
yeah, so here there's a many to one relationship between the like I think there's also this version which says that there must be one or more, but we still use the star.
Yes.
And it still works.
And it still works.
Yes. And basically the reason, I mean, maybe it would be nice if it accepted both, but the reason for that is that it does not really change the matching logic. It just says match a sequence of elements here. It doesn't really care if the grammar said, oh, it has to be at least one element. The matching is still exactly the same, and the types of X and TY you get out are exactly the same, so matching just doesn't care about that difference.
But then why make a difference between star and comma star, since it's technically the same
Those are
data?
not the same.
So it's the same data.
No. Well, so they're not the same data. So the difference is when you use comma star, what you get out here is in this version of it, after pattern matching the interior, you will actually get the same types out, but the data is actually not the same. If you do the most basic kind of pattern matching, you will get a T-sep array here. This is a comma separated array. And the reason why this is a different type is because the way this is actually stored as an array is you have an element and then you have a comma. And then you have another element and then you have a comma. So it's actually like every even element of the array is actually your data, and then the other elements are commas. You might wonder why you care about the commas, but that's because they are atoms, they have syntax and positions. You might want to put underscores on, or like error messages on them or other things like that, interpolate positions and so on, so it's still there.
But when you put x colon ty, then it's not the x and the ty array are not containing comma.
Right, but the syntax that is being matched does contain the commas, and the code that is being generated here has to pull out just the even numbered values and then put them into an array and then parse further the x and the y.
So this means we could rely on the number of comma to perform some. Do we want that? Okay.
Yeah. Many things are possible. Okay, so let's see. So if we want to match this whole thing.
Remove the comma.
Yeah. So if I think we can just say binders like this, and that will work. Although at this point it's starting to get a little bit ambiguous. Because there are several things that can be matched at these positions, especially once we get past the binders. So for instance, if I say, the next thing to come is an extends, and let's match an extends.
Question, so now you are matching $binder star.
Mm-hmm.
What if you want just $binders? Would it be possible when they change things?
So I can write $binders. And
what would have been the difference?
But well, this is relevant to what I'm about to bring up, which is that you'll notice that actually I wrote X for my extends, but I didn't get an X. What I got was a bracketed binder. In fact, even if I write binders, so if I write binders, I get one bracketed binder because I'm matching the next bracket, the next available thing, and that's a bracketed binder. And so this is going to match a mix-in with exactly 2 bracketed binders. Probably not what you want. And even if I write binder star, X is still a bracketed binder. So I'm not getting the next thing, right? I don't know if I can write. Is there even a syntax for being able to write X to question mark here?
Yes, yeah, exactly.
Are those the same? I think they're not the same.
No, and yet now it's, wait, that works?
This works.
Oh, yeah.
Well, it'll work, it'll parse, yeah. Oh, it does parse the extents.
But then binders, the type of binders changed when you did that? It was not a T-syntax array, was it?
Was
it a T-syntax array?
Yeah. So there's another syntax here that I'm using. I didn't write this. I wrote this with the star attached to it. And this is actually parsing a different type. You'll see that this gives me a T-syntax array. And this is also an array. But I think that this one is keeping track of the fact that it doesn't have the commas and stuff. So this is sort of the actual array coming out of the syntax. Whereas this is doing some kind of mapping in order to...
Can we see the type?
But I think this one is all... that's a lie. That's going to give you an array of T-syntax.
Oh, so it's the same.
It's the same in this case. But this is, I guess, this is the more flexible syntax in that you can put more things in here. Or like, you can, that was what we were doing before, right? We could parse some more interesting expression. Whereas with this syntax, it really has to be just an atomic token and then a star. But we can't put a question mark here instead of a star. And that's what I was remarking on. Is that because the question mark is an identifier character, you can't actually do this. You also can't put a space here because spaces have a semantic meaning inside the syntax quotation.
Same for parentheses?
You can do parentheses, exactly.
The parentheses
I thought.
don't work because it's not an atomic token anymore. So I think there is no syntax to be able to do this. Oh wait, no, there's the French quotes.
Wait.
No, but shouldn't you put the parentheses around? You don't have any more battery.
That's true.
I mean, suddenly the brackets work.
The brackets work, but they do something different.
Yes. I mean, do you want the question mark to match if they're exactly 0 or 1 binders?
I want to mark, well, yeah, okay, maybe in this case there's no,
Yeah, I mean, to me it makes sense that the question mark will match the next option of the part. It will not match the predicate binder.
okay. In any case, let's mark match extends, and then I think the next thing is, so here it says it's a type spec, which is not what we wrote here, it says op type. And that's because op type, unlike most of these things, is not a leading parser, it's just an abbreviation for this optional of type. So you could read this as type spec question. And so we also need to match this one using this. And then here you have, oh, and then I guess here you use a colon, and that's because a type spec itself is really a colon and then a term. So if we wanted to get the term out, that's this.
But you don't need to.
But we don't need to. Yeah. So, well, yeah, I mean, I'm not so sure how useful all this information is. Maybe it'll help people get their way through these different ways of pattern matching, like colon equals or where. Now this, I was remarking to Cyril earlier that this syntax is a bit hard to use because you can't actually interpolate with it. If you try to copy and paste this and use it as a class, it doesn't work. At this CE or where. If I use just where, then it's happy. But because this is one of 2 tokens, it doesn't work.
Oh, so the parser is kind of malformed? Is that the problem?
Well, no, I mean, I guess you could say the parser is malformed. The parser here is using
I see.
or of 2 things.
Yeah.
And actually it's mimicking what's being done in the official parser.
Yeah.
It's also doing this.
Yeah. That one was not written for matching, so that would make sense at least.
So as far as I'm aware, the only way to mimic that would be to have 2 branches and then produce like.
Or you can match on CEO where and assign the result of the match.
That's
Can you
well.
match on CEO?
So you could do this.
With
Can I even give?
No, there is no token for this. So there is no grammar non-terminal.
Yeah, I can't
I really want to give this a name, so you can talk about it.
Sorry, well, this is extremely interesting that I have a call now and you have cake.
Yes.
Yeah.
So we're out of time.
I think,
But this is something you can do if you're willing to copy and paste the entirety of your definition.
So you will tell me what is.
I think we have.
But yeah, I think this is a
I
good
think
time
we
to
have to
stop.
stop now.
Yeah. Okay. So
Thank you.
yes.
Thank you very much for